Welcome to The Explainer. Today, we are embarking on a truly fascinating journey. We're looking into a highly unconventional philosophical argument, a thought experiment that honestly attempts to challenge everything we fundamentally assume we know about math, numbers, and the very concept of forever. We are diving into a source text that takes an absolute sledgehammer to established mathematical norms. My goal today? To guide you through this material step by step and clearly lay out the author's precise logic, no matter how radical it might seem. So get ready to stretch your mind.
Let's just dive right in with an absolute bombshell claim directly from our source material. The twin prime conjecture is false. Now, for those of you familiar with number theory, you know this is one of the most famous unsolved problems in mathematics. It proposes that there are infinitely many prime numbers that differ by just two, like 11 and 13. But our author? They don't just question it. They flat out declare it false. This bold statement right here is the hook for everything we're about to unpack today. It sets up an incredible mathematical mystery that we're going to explore.
Section 1. A bold mathematical claim. So, the source material argues that much of what we accept at the highest levels of theoretical math might actually just be mathematical fairy tales. And to understand this, we first have to look at how mathematics traditionally handles conjectures that involve infinity. It's a very binary system, really. If a conjecture is proven, it graduates, right? It becomes a hard and fast theorem. But if it's disproven, it shatters. It's immediately discarded and is no longer a conjecture at all. The author actually breaks down the different states a conjecture can exist in. We just covered the proven theorems and the discarded ideas. The third state is what we usually assume about things like the twin prime conjecture, that it's simply unproven, just sitting there waiting for some genius to come along and crack it. But, and here is where the source text firmly plants its flag, the author emphasizes that some conjectures might simply be inherently false and therefore mathematically impossible to ever prove. Now, you might be wondering, why does the author believe the twin prime conjecture falls into that impossible category? Well, the text asserts that the conjecture hasn't been proven because it relies entirely on the wrong words. And the specific culprit? The word infinity. According to the source, the exact moment you introduce the concept of infinity into this statement, you guarantee that it's false. It becomes a fairy tale that the mathematical community just hasn't accepted as false yet. Section 2. The arithmetic gray area. Okay, we are now going to test the absolute boundaries of human logic. I want you to step into this thought experiment with me and imagine literally counting primes. Step 1. Suppose we have all the prime numbers up to a certain massive number. Even if it's astronomically huge, it is still a finite amount of primes, containing a lower finite amount of twin primes. Step 2. Eventually, as we keep pushing higher and higher, we enter what the author dubs the gray area. And step 3. This is the critical threshold. The text argues that at this unfathomable scale, arithmetic itself completely breaks down and becomes impossible. You literally hit a mathematical wall. The text explicitly defines this gray area as a boundary point where there is still a finite number of twin primes. However, because the sheer, overwhelming scale of these numbers causes the basic mechanics of math to shatter, you can no longer do arithmetic with them. And because you can't perform arithmetic on them, the author argues, they fundamentally stop being primes. Section 3. The end of primes. Let's look closely at what actually happens mechanically inside that gray area. The numbers become so astronomically large that any human or even theoretical ability to manipulate them just ceases. According to the text, you physically cannot add a 1 or a 2 to the number. The author's logic dictates that if a number exists at a scale where you can no longer perform foundational arithmetic on it, well, it inherently loses its defining properties. The number can no longer be called a prime. And that brings us to the ultimate consequential blow of this entire thought experiment. If the numbers are so large that arithmetic stops, and because arithmetic stops, those entities can no longer be classified as prime numbers, the stark conclusion presented by the source text is this: therefore, there are no twin primes anymore. Beyond that gray area threshold, the concept simply ceases to exist. So what does this actually leave us with? According to the source, because the sequence of twin primes is essentially killed off by the gray area, we are ultimately left with a rigidly finite amount of twin primes. Now, the author is very careful to clarify that we as humans can never mathematically establish or calculate exactly what that total finite amount is. The exact number is totally beyond our reach, but the total quantity of twin primes in the universe has a hard finite cap. Section 4. Redefining infinity.
If the twin prime conjecture breaks down because of the word infinity, what does this actually mean for our broader understanding of math? Well, on one side, we have the boundary of humans. The text states it's just a given that humans simply cannot do arithmetic beyond a certain point in the row of numbers, regardless of whether infinity exists or not. On the other side, we have the illusion of infinity. The author boldly claims that infinity simply cannot be defined properly. In fact, they add in parentheses, which is never. As long as we cannot properly define infinity, the author argues, we absolutely cannot use it to prove conjectures.
All right, let's bring this all together and summarize the final takeaways impartially. First, the famous conjecture that there are infinitely many twin primes is entirely false. Second, the inverse conjecture that there are only finitely many twin primes is true, even if we can't ever find that final number. But the author expands this rule drastically. This exact same limit applies not just to twin primes, but to the entirety of prime numbers in general. All primes are finite. We've reached the end of our explainer, and I want to leave you with this final, provocative thought directly inspired by the source text. As long as we cannot define infinity properly, are infinitely many twin primes just a fairy tale? It's a completely fascinating thought experiment. It asks us to ponder the absolute limits of human knowledge, the very boundaries of arithmetic, and the words we use to describe our universe. I really encourage you to think about this boundary between finite reality and infinite theory. Thank you so much for joining me on this deep dive.